Hi, this is Margo. This is Sunday afternoon, February the 14th, 2021. I hope everyone is safe and doing well as possible. We made it through another week. We're here, and I'd like to welcome everyone to the show. This is my weekly update that I will be putting on YouTube for everyone. We're going to go over methane. We're going to go over sea ice, and there's some new things on the Navy website, and I'm going to start off with an article, a recent article, and this is the press release for it from Leeds University of Leeds out of the UK. And this is the press release for this paper that was just published. And so this came out January 25th of this year. Global ice loss increases at record rate. And we knew this, but you know, they're finally coming around and saying, yeah, it's really happening. And here's a picture. The rate at which ice is disappearing across the planet is speeding up according to new research. And the findings also reveal that the Earth lost 28 trillion tons of ice between 1994 and 2017, equivalent to a sheet of ice 100 meters thick covering the whole of the UK. So the study went through 2017, so they don't have 18, 19, and 20, and now we're into 21, and it's speeding up every year. The research is the first of its kind to carry out a survey of global ice loss using satellite data. Scientists led by the university found that the rate of ice loss from the Earth has increased markedly within the past 3 decades, from 0.8 trillion tons per year in the 1990s to 1.3 trillion tons per year by 2017. Ice melt across the globe raises sea levels, increases the risk of flooding to coastal communities, and threatens to wipe out natural habitats which wildlife depend on. Well, there won't be any wildlife much longer, or any of us much longer. Here's a quote. The ice sheets are now following the worst-case climate warming scenarios. And this is a quote from Dr. Thomas Slater, Center for Polar Observation and Modeling. The findings of the research team, which includes the University of Edinburgh, University College London, and data science specialist Earthwave, are published in European Geosciences Union's journal, The Cryosphere. Funded by the UK Natural Environment Research Council, the research shows that overall there has been a 65% increase in the rate of ice loss over the 23-year survey. This has been mainly driven by steep rises and losses from the polar ice sheets in Antarctica and Greenland. Lead author Dr. Thomas Slater, a research fellow at Leeds Center for Polar Observation and Modeling, said, although every region we studied lost ice, losses from the Antarctic and Greenland ice sheets have accelerated the most. The ice sheets are now following the worst-case climate warming scenarios set out by the Intergovernmental Panel on Climate Change, or the IPCC. Sea level rise on this scale will have various serious impacts on coastal communities this century. Well, I don't think we're going to have this century to worry about. Dr. Slater said the study was the first of its kind to examine all the ice that is disappearing on Earth using satellite observations. He added, over the past 3 decades, there's been a huge international effort to understand what's happening to individual components in Earth's ice system, revolutionized by satellites, which allow us to routinely monitor the vast and inhospitable regions where ice can be found. Our study is the first to combine these efforts and look at all the ice that is being lost from the entire planet. The survey covers 215,000 mountain glaciers spread around the planet, the polar ice sheets in Greenland and Antarctica, the ice shelves floating around Antarctica, and sea ice drifting in the Arctic and Southern Oceans. Rising atmospheric temperatures have been the main driver of the decline in Arctic sea ice and mountain glaciers across the globe, while rising ocean temperatures have increased the melting of the Antarctic ice sheet. They don't talk about the active volcanoes under the Antarctic that's heating it up too. For the Greenland ice sheet and Antarctic ice shelves, ice losses have been triggered by a combination of rising ocean and atmospheric temperatures. During the survey period, every category lost ice, but the biggest losses were from Arctic sea ice, 7.6 trillion tons, and Antarctic ice shelves, 6.5 trillion tons, both of which float on the polar oceans. Dr. Isabel Lawrence, a research fellow at Leeds Center for Polar Observation and Modeling, said, sea ice loss doesn't contribute directly to sea level rise, but it does have an indirect influence. One of the key roles of Arctic sea ice is to reflect solar radiation back into space, which helps keep the Arctic cool. As the sea ice shrinks, more solar energy is being absorbed by the oceans and atmosphere, causing the Arctic to warm faster than anywhere else on the planet. Not only is this speeding up sea ice melt, it's also exacerbating the melting of glaciers and ice sheets, which causes sea levels to rise. Not to mention the methane coming up and the permafrost melting. Half of all losses are from ice on land, including 6.1 trillion tons from mountain glaciers, 3.8 trillion tons from the Greenland ice sheet, and 2.5 trillion tons from the Antarctic ice sheet. These losses have raised global sea levels by 35 millimeters. It's estimated that every centimeter of sea level rise, approximately 1 million people are in danger of being displaced from low-lying homelands. Despite storing only 1% of the Earth's total ice volume, glaciers have contributed to almost a quarter of the global ice losses over the study period, with all glacier regions around the world losing ice. Report co-author and PhD researcher Ines Otasaka, also from Leeds, said, as well as contributing to global mean sea level rise, mountain glaciers are also critical as a freshwater resource for local communities. The retreat of glaciers around the world is therefore of crucial importance at both local and global scales. Just over half, or 58%, of the ice loss was from the northern hemisphere, and the remainder, 42%, was from the southern hemisphere. And that's the article. And here's the link to the actual paper it's called Earth's Ice Imbalance, and it was published in the European Geosciences Union's journal, The Cryosphere, on January 25th, 2021. There it is. So there's that. So I already posted that in my community section on YouTube, but I will leave a link in the show links below. Now, so keep this in mind as we're looking at everything. I'm going to close that out. Just keep this in mind as we're looking at everything, at the methane and the sea ice and all of that, and earthquakes, because, you know, as the ice melts, then it changes the weight on the tectonic plates, and the plates move up and down with isostatic rebound, and we have bigger and more disruptive earthquakes and all kinds of things happening. So let's start out now with our NOAA methane data. I've been tracking this since March of 2019 at the 477/469 millibar reading. About a year ago I started tracking it daily to just out of curiosity, and I'm glad I've done that. And before that it was on a weekly basis. So we're seeing exponential rises in methane. So here we are for the Met-1 satellite in the morning for yesterday, the 13th. The mean or average was 1,888 parts per billion, and the range was 1413 to 2380 parts per billion. This pink color is the highest zone, and that reading that's a range between 2,000 parts per billion and then whatever is the high number here in this range. So it's going to be different on each graph. And we've even got pinks coming down over Africa now. And even look down here at the tippy point of Africa, and here's a little bit of pink in the middle of the Indian Ocean. Here it is in the afternoon. The mean was 1889. The high reading was 2475. On the Met-2 satellite in the morning, the mean was 1868. The high reading was 2407. And in the afternoon, the mean was 1869. And the high reading was 2418. Here's the spreadsheet and chart that we've been looking at. Here's the data for the 13th. Here are the means added up and divided by 4, and we come out with an average of, for this level, of 1878.5 parts per billion. That's showing an increase over our report last week. A decrease over last week of 1 part per billion. I was thinking increase because this one last week it went up. It spiked up 5.5 parts per billion, and now this week it went down 1 part per billion. So here's our chart. We're just hovering around this 1880 line for a while now, and we reached the lowest point for this winter, which is supposed to be the cooling season. We reached the lowest, I think, on January the 12th. And last year we reached the lowest in December of 2019. And so for this season we hit the low a little bit later, so it stayed higher longer. So so we've gone down just a little bit this week at 0.5. Now, since since the beginning of my charting this, from March the 1st of 2019, we're showing an increase of 21.25 parts per billion. And in the last year, see, I have the data from the 13th of last year, 2020. It's gone, we're up, can't talk, 13.25 parts per billion. We're that much higher than this time last year. And so we were lower. We didn't get down to the lowest part. We didn't get even close to that. The lowest it reached during the last cycle was 1861.75. And the lowest we got this time was 1873.65. So here's what it did this week. Here we are last week. This was Saturday when I did the report on Sunday. So the Saturday data last week was 1879.5, where it had gone up 5.5. On Sunday it went down 1 part per billion. Monday it went down again 1.5. Tuesday it jumped up 2.25. Wednesday it went up 0.5. Thursday it went up 0.5. Friday it went down 1 part per billion, and Saturday it went down 0.75 parts per billion, showing an overall decrease of 1 part per billion. So at one point we were for a couple of days we were up above last Saturday. And then I have at the top up here, this is where I started tracking it. Actually, I started being consistent after the 16th, but I'd started getting more in between the weeks here. So I do have the 13th data, and here it was 1865.25 last year. This time last year. So we're up 13.25 for the last year. So I don't know what's happening. I don't know how fast it's gonna start going back up, or if it's going to hover around this 1880 for a while. It's just hard to say. But I will keep everyone informed. Now, we'll run the CAMS data. This is the Copernicus Atmosphere Monitoring Service website. They're out of the EU. We're looking at methane. We're going to look at Saturday the 13th to compare with the NOAA data, Arctic view, and surface level. There's our color ledger. Got to get this lined up. So the data is for Saturday, and the forecast period is Sunday through Wednesday. So even though it went down slightly, it looks higher to me, at the surface level. And it can be different readings at the surface than at the 500 HPA. So overall, we're seeing higher background colors coming up, and we're see these lighter greens. That's a higher methane reading. And you see the yellows coming in. That's a higher reading. Now look at the wave move out across the Arctic. Now this is coming up through the sea ice there. So it's huge waves moving out across the Arctic. Now this area around CAMS Island, this is part of Severnaya Zemlya. This has been a problem area for over the last year, with it spewing up right here. And it's getting worse. Look at this, and look at it in the forecast period, how it just spews up and balloons out. And they don't test there. They test around the sediments around the coastlines more than anything. That, as far as I know, none of the tests have been out here. I don't know if it's part of a restricted zone from the nuclear weapons testing around Novaya Zemlya that Russia did. This whole island, Novaya Zemlya, was like a secret military base. For the Russians back during the Cold War, they tested all kinds of nuclear weapons, nuclear weapons underground, above ground, on ground, in the water, all around. And this is where the Tsar Bomba was dropped. It was the biggest detonated atomic bomb. It was a test, and it was 50? I think it was 50 megatons. Anyway, it was the biggest one that was detonated. It was right over here. And so this whole area is radiated, and especially the Kara Sea. It is the most radiated sea in the world, and I'm sure so the Kara Sea goes all the way up to this area, and then on the other side of Severnaya Zemlya, this is the Laptev Sea, and the Russians also dumped nuclear waste from all their experiments in the ocean here. It's all kinds of stuff, and there are reactor rods, and there are some sunken nuclear submarines. They said 4. That's what they're saying in this one article I found. 4 sunken nuclear submarines and a whole bunch of reactor rods and I don't know what all. And so that, if that eats through into the ocean floor, those are hot, and then that can melt everything around it. And if there's a big thing of hydrates, big pocket of hydrates and clathrates in the ocean floor, that'll it'll just start coming up. That'll melt all that. So that's my theory about what's going on up here and why no one is testing up here and no one is doing anything about this. Now in the article I found, the Russians are they're going to try and clean up this area. They're going to try and retrieve as much of the radioactive material that they can, because this is part of the Northern Sea route that the merchants are wanting to use. As the sea ice melts, the merchants have great plans, and they is going to cut out a whole bunch of time and effort to just do a little shortcut right through the Arctic here, all the way around to China, and that's a lot faster than going overland or you know, any other ways that they have to get things moved. So, and it's military use, and they're going to be exploring for oil, and they're going to be getting methane and using that for liquid natural gas, and you know, it's a whole thing. I kind of got off on a soapbox there, but this just so angers me and disturbs me to see this. And it's like when I'm looking at NASA Worldview and I see all the beaming, and it's like, oh my God, can't people see this? Look at these yellows coming out all the way across. And this is coming up through the sea ice. Now a hole has developed here by CAMS Island that we can look at under the with the nighttime layer on NASA Worldview. There's also a hole that's developed in the ice up here in the Baffin Bay next to Greenland. It's a huge hole that's, you know, it's no one's talking about it. And then, of course, we see it spewing up here on the north coast of Alaska, and we've got it, see the high releases over here in Canada and North America, and it's just all the way around. We're doomed. I mean, we're done. We're done. And if people think that we're going to fix all of this, oh, and look at this. See that on Kamchatka right there? That's probably a volcano. We had some high sulfur dioxide releases today. Over there on Kamchatka, so that's usually a volcano. They have earthquakes over there too. It's all very active up there. Okay, here's the North Pole view. We can see the whole northern hemisphere. Now look at how this high reading still coming up in the Bengal Bay next to India. India's still filling up. Here's China. The white spot by Beijing has come back. It's a little easier to see when we look at the global view. Look at Korea's covered up. See the wave moving out? That wave of green. Europe, you're coming back to life. Here's the Persian Gulf. And here's the U.S. Look at this. Now, once all that the snow and ice gets done from Texas over and through the Midwest, there's going to be huge methane readings. Huge, humongous. You just wait and see. This will be black once the temperatures come up because of the water. Look at that. See, in certain areas of the U.S., they're very high, just depending on what's going on there. Like in West Texas, that's a lot of oil drilling there, and there's just a huge release constantly going on there. California, some of these areas are very densely populated, thus we see the high methane. Other things are from drilling. Just depends on the source. Now we'll look at the global view. Well, I'm kind of chatty today. We're 30 minutes in, and I'm just rattling off. So, see the dark blue that's coming in now? Remember last time most of this from about the equator south was in this purplish color. Now we're getting the dark blue. That's a higher methane reading. That's 1800. And then the lighter blue, see, that's coming in further south. So these are signs that methane is on the rise as well. I have not felt well this week. Had a sore throat most of the week, starting around Tuesday or Wednesday, and I think they sprayed something weird in the air. It came on suddenly, and it's gone today. It's better, but I've just not felt well. And anyway, okay, here's 500 HPA. This correlates with the level that we saw on the NOAA data. Now here's the highest reading. It's probably streamed up from China and then moved up over Russia. Here's some more. See the dark red here, and here. We're seeing green coming in further south. See the green coming in even over the Antarctic. So it's spreading out more. Higher readings are spreading out more. Now we'll look at total column. So the highest is here over China, and then India. We've got some red down here over Indonesia. They've had all those earthquakes, and then we had that 7.1 off the coast of Japan, and some large earthquakes after that. I always get concerned when I see Fukushima, when it was next to Fukushima. But luckily it was far enough out in the ocean that didn't do anything. Now we've got reds popping up here. Look, right there. If we zoom in, let's go to South America first. If you zoom in, I'll show you. You really get a lot more detail. See, here's reds popping up in South America, and then the red-orange. That's the next color up from the red. So that's higher reading. We normally don't see the total column reds over South America. Now let's go to Eurasia. This is Siberia. We can see all of Russia here, pretty much. I see it's red right up here. This is Russia, and let's see. Yeah, this is Kazakhstan here, and then this is Russia right here. This is Mongolia, but we've got some reds here, which we normally don't see in total column. And here's India, and then on over. So, see, you can really get a more detailed view when you zoom in like that. And if you want to look at southern, let's see, They have a lot of different views of Asia. Southeast Asia and Indonesia, that's a good view. Let's see, we got, here's Australia down here. So it goes from Papua New Guinea all the way over, and we get over to Taiwan. We don't get Japan in this view. Japan's up here. And we get the Philippines and all of Indonesia. So see, we've got reds even down here in Indonesia. So that's just what we've got. Oh, I wanted to show, while we're here, ozone. Let's go to Sunday. See, it's quite thin there. We'll go to global. Now see, this makes no sense because the highest ozone readings are in North America. And I think it's from bad ozone coming from China, and it's kind of gathering. But it doesn't make any sense with the dark up here, and ozone is supposed to be created with the sunlight, interaction of the water vapor with the sunlight. And so wouldn't you think that you would have high ozone readings around the Antarctic where the sun has been up all these months? But no, we don't have any reds down here. We have very few yellows. The solid yellow is 300 Dobson units, and we have very little yellow anywhere. And then we have this weird black up here in the northern hemisphere that I think is from bad ozone and from pollution. And look at all the holes, and you know, it's all below average, below normal, and we're losing the ozone layer, losing it. And the more pollution there is, the more it eats, the earth can't make its ozone, and it just eats it up. And see this. So I'm very upset. I'm very disturbed today. Let's look at the Antarctic. See? I remember the huge hole that was over here over the winter time. It was in the danger zone. It even got down past the black. There was a white hole. It got below 100 Dobson units. Remember that? That was in the middle of their winter. And see, they're in their summertime. I mean, the sun is starting to go down there, but we should be seeing reds around here. We should have yellows over all of the landmass. This is just awful. And with the ozone layer so thin, the UV rays are coming through, and this is another reason the ice is, I think, the ice is melting so fast. See, we've even got a little aqua here. So there's a hole opening up there in the South Atlantic. But I don't know. And I'll show you one more thing. Global. I'll show you two more things. I'll show you sulfur dioxide. Here we are today. We still have it high in this little elbow over South America. But here's a new high reading here from Kamchatka. These reds that you're seeing from China and India and Saudi Arabia, that's from pollution. Then when we look at 500 HPA, that's where it zips up in the atmosphere. See the high reading here? This is probably volcanic, like I said, from Kamchatka. They're volcanoes all the way up and down the peninsula there, and then these Kuril Islands are all volcanic. And over here in South America, we have volcanoes all around this west side, and this is a highly active geologic region with earthquakes and volcanoes. And plus, when we see plate movement, we have high release of pockets of sulfur dioxide here that relate to plate movement. That's what I've found recently. And I wanted to show carbon dioxide today. Now, last year, I remember looking at carbon dioxide in, January, February, and there were some blue-greens down here in the bottom part in the southern hemisphere, but no more. See, it's all kind of this beige cream, brown, moving into the brown, and then look, see how dark it gets as you go up. Look at this. Here's China. Look, here's over Africa. That's from the fires. Now, look over here, in just north of the Mediterranean. Here's Africa. This is the Mediterranean. Here's Italy. Here's like Turkey and all those. And then the U.S. See, it's heavy over Texas, and that's probably from the high electrical use that they're having to do. Electric and burning fireplaces, wood stoves, anything to try and stay warm. They're trying to stay warm. It's awful. I was watching shows earlier today, and it's awful. And they're saying they may be having to shut down the power grid in some places because they just won't be able to produce the electricity. And the electricity is gonna be really high during these times. They're gonna gouge the people who, it's awful. I mean, this is just Satan's world now. They don't care. They don't care about us. It's Satan's world. I can't wait to go home. I just can't wait. Anyway, let's move on. Okay, I'm done with that one. Okay, now we'll go to the sea ice report. Here, this is from Climate Reanalyzer for today, the 14th, sea ice and snow cover. This is the North America view here. We can see the white. There's the snow going all the way down through Mexico, down into the Yucatan, all the way down. All over, it's crazy. But this is, people don't understand. I know my audience does. You're very smart. You're very smart, and you've been studying abrupt climate change, abrupt irreversible climate change along with me, and a lot of you have been doing it for many years, much longer than I have, and I'm fairly new on the scene. But just from my studies, I've noticed the change in the weather and stuff, and people who are climate deniers will say, oh, well, where's the global warming? Where's the global warming? Well, this is because of global warming and abrupt irreversible climate change, because the jet stream is broken, and with a huge hole in the jet stream, then all that cold air doesn't stay up in the Arctic. There's supposed to be a polar vortex that keeps the cold air up here most of the time, but we've lost that, and now there's a huge hole, and so all that cold air is just being released all the way down. I mean, it's not rocket science. Seriously. I don't know what's wrong with people. And they won't listen. They've already made up their minds that man cannot influence the environment. We can't hurt Mother Earth. We can't influence the environment. And I just want to, well, anyway, whatever. So, here we are. And they'll never learn. They won't know, and they won't listen. And so it doesn't matter. It doesn't matter. We're all going to die soon, and we all need to get our spiritual houses in order. That's my message. And that's been my message all along. And we're in hospice. The whole planet is in hospice. The whole planet. Sunday, February 14th, and it's still open up here by Svalbard. Here's we have a little bit of regrowth in the Barents Sea, and here around the Russia coastline, and out here in the Pacific between Alaska and Russia, and up here in the Okhotsk Sea, Russia. And mainly it's been thickening, trying to thicken, and the Baffin, here's the Baffin Bay. Here's the Hudson Bay. So let's see what it did this week. Here we are, last Sunday, the 7th. So I'll just click through. See 8th, 9th, 10th, 11th, 12th, 13th, and 14th. So you see the white. You can see it getting whiter and whiter and whiter on land here as the snow came down, and is just moving on down. But not much regrowth. The extent is still very sad looking. So there's that. Now, here's our sea ice thickness. This is from the Navy website, U.S. Navy website. Arctic sea ice thickness for today. And the purple is the thinnest. The dark purple is about 1 meter thick. The bright aqua is about 2 meters thick. The dark aqua is about 1.5 meters thick. And I think the dark aqua, yeah, that's right. And then when you get into greens, you're getting a little bit thicker. There's very little red, which goes up into 4 and 5 meters thick. So the thick sea ice is done. We're not going to have that. The big thick covering of sea ice, that's gone, and that's not coming back. So there's a hole here in the Baffin Bay that's opened up. You can see it's white here. There's no ice here, and it's to the east, to the west of Greenland, this north part of Greenland, just at the end of the nearest strait. It's huge, and I'll show you that on NASA Worldview. So here's Svalbard. Here's where it's trying to have a little fringe of ice come back. Here's Novaya Zemlya, and here's where the little fringe of regrowth that's happened here in the Barents Sea. Now the sun's up. It over about to here on Novaya Zemlya. The Yamal Peninsula is all in the sun. A lot of these coastlines are in the sun now, so you're not going to see much refreeze going on now that this, I mean, it's a low level sun. It's on the horizon, so it's not bright sunlight. It's a dim twilight sun, but it is coming up. Here's the Bering Strait. See, look at this big area where it's quite thin. And here's what was left of the thickest sea ice, this portion here that had been up here over the archipelago in Greenland, and we've been seeing during this winter that it's been sliding down, and now it's smashing and piling up in along the Alaska coastline and in this Beaufort Sea, and it's scooting out. It's thickening. We're seeing some darker aqua too, but it's also compressing and moving out. Here, up here, let me zoom in a little bit more. Here is Komsolomitz Island, and see the light purple here? That's where the ice has opened up, and where the methane's spewing up, that's where it is. I'm certain it's from nuclear stuff. 5 years from now, if we're still here, they might put out some kind of new research. Oh, new research shows there was a nuclear submarine that sunk there and ate through, caused all this methane to release. Here's a 30-day animation. The data goes back for 3 weeks, and the forecast period goes out for a week from now. I'll zoom in on this. Now look at this area. I don't know what's causing this, why the water is so warm there. But you know, it goes through a whole fluctuation where it melts and refreezes and melts and refreezes. I don't know. Unless there's a crack in the seafloor there and warm water's coming up. I don't know. Let's see, you're not, once it gets to a certain stage, you're not seeing a lot of change in this sea ice. It's just compressing. It's just, see, just and kind of expanding and compressing there. So let's go on. Here's the Beaufort Sea view of the sea ice thickness. Here it is for today. Here's this just little tiny bit of red here on this Canada coastline, and here along the North Alaska coastline. Just a little skim of red. Here's some green. So the green is about it's going into 3 meters thick. See, it's quite thin around the coastline here. See that? It had tried to anchor here, but the ice drift just kept pulling it away, pulling it away. Here's the 30-day animation. There's that. Now, this is new. This is from the Navy website. This is a new model that they put up this week on the 12th. So just a couple of days ago, they started releasing this data. This is the Baffin Bay, only about halfway up though. And I'm going to start showing this. I'll show you. Here it is. And so when you go to the link for the polar oceans, now they've added it in here between the Arctic Ocean and the Beaufort Sea. So you just click Baffin Bay and you have sea surface temperature. This is a good one. You can see how warm the water is. That's why the ice is not freezing further down. Sea ice thickness, concentration, speed and drift, and ice strength. So if you look at the sea surface temperature, actually that was one of my slides I had up, but we'll look at it here. I'll show you where this is. Where's my thing? So it only goes up to here, about here. So it's from here down. So it's only about halfway. So we can see it's quite warm. It's up to 4 degrees Celsius. That's the temperature for C. So there's no way ice is going to form at 4C. And this is pretty salty coming in from the North Atlantic. So it's going to have to be below 0 in order for it to freeze. So here's 0 at this kind of going into the dark aqua. 0 is right about here. And then the blue going into purple is -1. Then the white is -2. So this is -2 or lower here in order to have ice. So here is the sea ice thickness here in the Baffin Bay. Let's see, it's got some thicker ice a little bit around the coastlines. Now here's the forecast. And it goes only back to the 12th, since that's when they started. And then it goes out to the 21st for this model. And you can see the ice moving out. See it moving out? This is one of the exit points for the sea ice, is through the Baffin Bay. Here's the sea surface temperature. We just saw that. Oh, I wasn't quite ready for that. Let's go back. Where was I? So, what else was I going to show? The speed and drift. I learned some things here. So you can see the direction of the arrows, it's all going south, so it's an exit point. Now here's some big arrows going west, so here's from water coming in, and so the water coming in is meeting the water flowing out, or the ice coming out. And speed and drift, we look at this. So it's a dance, just like we've seen with the others. We can watch the sea dancing here with the ice drift. So I thought I'd share that with everyone. Now, let's move on. Where are we? Oh, okay, Antarctic. Here's the sea ice thickness for the Antarctic for today. We can see it's a lot of melt. See, this Ross Sea is open. See how close in it's melted, and then it's quite thin, down to less than 1 meter even, and all the way up to the coastline in a lot of places. See, it's melted here along the Weddell Sea, in the Weddell Sea along the ice shelf, and coming in here around the peninsula. Here's the 30-day animation, so we can see what's been going on. It's been in high melt. So there's that. I think that's all of those. Okay, next we'll look at the National Snow and Ice Data Center, Sea Ice Index. We're looking at the Arctic on the daily blue marble. This is as of yesterday. This is sea ice concentration, and the blue shows it not very concentrated. Now we can see the hole here by Greenland. This is just a hole that's opened up in the ice. Let's see the blues around here. We want to see solid white, but we're certainly not seeing that, especially right there by Greenland. Here's the chart. Arctic Sea Ice Extent. The dotted line is 2012. That was the year that it was the lowest until this year. See, the blue line is this year. We've been below 2012 almost the whole time for the winter. And then, I don't know, see, it went up for a little bit, and now we're about tied with 2012 on the refreeze. But remember that the sea ice was much thicker in 2012 than it is right now, so it's in very poor shape. Very poor. Wish I had a better report for everyone. Here's the Antarctic and sea ice concentration. We can see the blue where it's not very concentrated. And here's the chart. Antarctic Sea Ice Extent. The blue line is this year. This gray line is last year. Last year we were at the lowest on record, and we've kind of we've been dropping real fast, and now we're below last year. It looks like to me. Looks like we've dipped below last year's line, so we're at the lowest on record for Antarctic Sea Ice Extent for this time of year. So this is why I presented that paper at the beginning, the ice loss around the planet. And I know I mainly concentrate on sea ice, and you know, they did say sea ice, but they mainly talked about the ice sheets, you know, Greenland and the glaciers on the Antarctic, and then the glaciers on land too. So there's that. Now let's take a peek at NASA Worldview. Let me refresh this, see if all the data's in. It mainly is. So we're looking at sea ice concentration. The black circle is where it's still in the dark. So you can see that the sun has come up on a lot of this area. See, here's Novae Zemlya. Half of that is in the light. All of the Yamal Peninsula. This Russia coastline, that's in the light. This area, right along in here. Alaska and Canada along here, that's in the light. Bering Strait. So I don't know what kind of refreeze is going to continue. But I want to zoom in to Greenland. Here's the hole. And what we saw on the Navy website was the white area. It came way down. It was a big triangle shape. Now I want to show you. I'm going to turn on the nighttime imagery and turn off the sea ice. And here is the hole. You can, if I zoom in, see it's a huge hole that's opened up right here. This is the nearest strait. Kind of hard to see up there. And then it's opened up right at the bottom of that, and that's about as much we can make out there. But if we go back, let's go back to, let's say, a week ago, the 7th. See the ice was up. See the lights, that's on the land. And here's a tiny little hole here. Now if we go forward, we can see how much bigger it is here on the 8th. It's opening up. Here's the 9th. See it's open. See it's bigger here. Here's the 10th. Look at that. Unless they're running an icebreaker through there, I can't imagine. I don't think it's an icebreaker. I mean, this part. No, I really don't think it is. I think it's just melting. Here's the 11th. Look at this. Look at on the 12th. It's open all the way down here. You see? See that? And the 13th, here's a little bit of streaky ice coming back. And 14th. So, see it's open even way over here on the left. So that's not good. That's just not good. Now, I want to show also, while we're looking at night vision, I want to go up to CAMS NOAA. Let's go back to the 7th. Oops. Now see the lack of, see the different colors? That means that there's very little ice there. So this is the area we're going to be focusing on. Now I've got the night vision on. I'm going to turn off sea ice. Here's the hole. You see that? Here's the island. Here's the edge. And here's the hole. And here it's thinner. But look at that. Huge hole. Here's the 8th. See, it's moved over. This is another little tiny island right here. So it's opened up around that and over here. Here's the 9th. Here's the 10th. See, it's opened back up down here on this end. 11th. It's getting darker. A little bit harder to see. 12th. Because the sun's coming up, I think. But you can see the hole here all the way around. 13th. And here it is today. It's hard to tell there. I don't know what this thing is. Maybe it's a cloud. I don't know. But that's just kind of flipping me out. And you can't tell from this little pink color. You wouldn't know that the pink color means it's a huge hole there. You wouldn't know. So this red thing means there's a hole there. So that's bothering me. So let's turn off the sea ice concentration level and let's just take a peek at the ice. This show is going to be long, I'm sorry. I have a lot to go over. Let's start down here in the Baffin Bay just to take a peek. This is our first good peek at the sea ice. Look. Here it is. There it is. Beaming. You see that? See the ripples? And so the hole that we saw is right up here. So maybe by next week this will be in the sunlight and we'll be able to see what's going on up there. Oopsies. Now let's go. So those are a bunch of clouds. Here's some ice edge, it looks like. Here's a hole. Uh-oh, look at this! Oh my gosh! I didn't see this before. I didn't zoom in. What is all this? You know, that's not normal. That's crazy. Beerenberg, South Glacier. He's in the sun. He's being beamed. Look at that. That's not normal. Look, here's another one. There's a little hole. There's another one. See that? Anyway, I'm getting off track. Here's the Kola Peninsula. That's Russia. Secret military outlook. Here's Novaya Zemlya. Here's some sea ice that's come back. The little fringe of ice on the west side. Here's the coastline. See where the ice has come back around the coast. See there. There it is. It's thin, but it's there. Here's the Yamal Peninsula. Here's the sea ice. Here's some clouds. Now, see this? This is where an icebreaker has been. See that huge thing? So, what we saw and part of that by Greenland, it almost looks like it could have been icebreaker. But I don't think they opened up all of it. This is the Gulf of Ob. Now, that's a cloud. Now we'll hop over to Russia and the East Siberia Arctic shelf right over here, and it's cloud covered. We can't really see anything. Here's the Bering Strait. Here's Alaska. Look. See the coastline. It's very thin right there. Just not much there. And here's the ice that's piling up. Supposed to be piling up along the coastline. But see, look at all the space between the thick ice. See? There it is. That's our thickest sea ice. What was left piling in. Now we'll take a peek at the Antarctic. Here we are today. Here's this western peninsula. Now I've been following A68 iceberg and it's been breaking up. last few weeks. They've been beaming the crap out of it. Look at this. See all that? See the beaming? This is, yeah, this is South Georgia Island, but you can see the ripples in the clouds. See, that's from the beaming. See, it goes up. Now, here under the cloud, here is the largest piece that's left. Here's another piece. Here's some more. It's been breaking up. Here's another piece. Here's another one. Here's what's left of the finger that had broken off of the front. And see the pieces, that's breaking up. But look at see the lines? That's beaming. They're beaming the whole area. And it's totally unnatural the way these clouds are being made and manipulated. And this is happening all around the globe, all over the place. It's really obvious when you get a little island like this, where it goes right down to one little point. I mean, it's very obvious to see that you can see. Let me go back. I'll go back. Let's see, last week to the 7th. Okay, here we were. Here was a piece here on the 7th. Here's the island. Let's move forward. Here's the 8th. 9th. See, it's kind of spinning around. These are pieces that had broken off here. Here's the 10th. This is a pretty good picture. See, here it is, the biggest piece still. And see these long pieces and pieces there. Here's the 11th. Look at the beaming. 12th. It's under the cloud. Look at this. Over here. See that? There must be a radar thing over there. It's coming up. Or they might be doing it from outer space. Who knows? They might be doing it from a quantum computer. Look at this. Yesterday. See the circle? The line? Look at this. Oh, I get so upset. Anyway, here's what's left of A68. Our huge iceberg. They're going to make sure it doesn't run into anything. They're going to beam it till it's all disintegrated. Look at this. It's just more and more blatant and in your face. And I'm sensitive to all this stuff. I can feel it when it's happening. Look at this. Here's more. Here's the Western Peninsula. Here's the tippy point. There have been earthquakes down here, right where the beaming is. Here's Larsen Sea ice shelf. Here's what it looks like today. And here's the sea ice. This area here is where A68 had broken off. In the wintertime, like Larry said, yes, in the wintertime. And the glacier that burst in India is in the middle of winter. So go figure. What is that about? Why is it doing that in the wintertime? Now down here Now this is bothering me too. You see, so here's Pine Island Glacier, here's Thwaites, Doomsday Glacier, and it's covered with a big cloud, but when you zoom out, so you see this area, that just doesn't look normal. That doesn't look right. It just looks like they've just put that in there as a big cloud so that we can't really see and see the line. It's so straight. See the straight lines. You don't see that in nature. You just don't. Or is that a cut and paste? That's a cut and paste. Whatever. But for whatever reason, they're keeping this area cloudy so we can't see what's going on here. And I'm surprised this ice is still here. They're trying to keep it there. And this ice, see, now this is the Thwaites Glacier, the tongue, that all is broken off, and at one point it was gone. I saw that. I was looking back through Worldview. At one point this was nothing here, and then it refroze. See, there's clouds. Okay, here we are on the 12th. Here's a good view. See that? But still cloud covered on Pine Island. See? We've only had like 1 or 2 days without a cloud over here. Since the sun's been up down here. See, even there we've got clouds. See? So that's being manipulated. It's just not normal. Normally we have some good days where we can see something. Here's January 31st. That was the last good day. And there was a lot going on. See all those cracks? And it had cabbed off here last year, and then it refroze up to here. But see the flow? This is the glacier melting and flowing. So I just find it kind of hard to believe that this hasn't melted. See. So that was the 31st. That was 2 weeks ago. That was the last good day. So you can see it melting all the way up to the edge of the ice line, the ice shelf line. Here's the Ross Sea. It's open. See, all that's open. Just a little wisp of ice here. Here's the ice shelf. Here's a really good view of Ross Island. Here's Mount Erebus. This is the shadow. This is a volcano. And McMurdo Station is right up here on that end. research station. And see these rocks, they've all melted. There has been high ice melt in these. See the channels there coming down. Look at that line. See, there's a hole in the ice there. There's a hole. Here's some more flow where it's melting. That's all. Look, that's all melted there. Here it is. See it here. Now some of these are shadows because the sun is at a lower angle. But you can see the melt that's going on. See it's flowing out. See there. Clouds. Here's the Anomaly ice sheet. Now this ice is kind of pulling out. I'll show you. There's a good picture from yesterday. See, it's kind of pulling out. This had been up here by the edge. So it's pulling out. This part looks more anchored. But see, this, it's moving out there next to it. So we've got some clouds over it, but you can see the melt and the flow there. See, here it is today, right here. See all that? Here's the north side. Here's the brunt ice sheet. It's under a cloud. Look at this. Anyway, it's just strange. Everything is strange. Nothing is normal anymore. Clouds. Here we go. On the 11th. No, there's a cloud over that. We can't really see it. Tenth, 9th. Here it is on the 9th. This is a good view. Here's the chasm. See that big long crack all the way across there. And then this is the Halloween crack. And then this is the new one that they found this summer. See, it's cracking here. All of that. So let's go back to today. So now we've got clouds over all of that. See, it's pulled away from the ice sheet there. See the sea ice? Pulled away from the ice sheet. You can see the ice, see the cracks. There it is. This is the Weddell Sea. And we're back to Larsen And that's it. That's our tour of the North and South Poles. And we'll zip through Climate Reanalyzer. I was going to show earthquakes, but I can't do it. And then we'll finish up. Here is 2-meter temperature anomaly for today. So look at Greenland, it's in the red. North Canada, it's in the red. So all of these are in the Arctic. Now the Arctic is up 1.1 C higher than normal. The Antarctic is up 0.4 C. So we got some reds. And now look at this cold Arctic air. See how it's just settled down, swooped down over Canada, all the way down into Mexico, past Texas, all the way down into Mexico, and then covers up the whole middle of the United States. And it's all going to be moving east, slowly. It's moving slowly. And see, we've got a lot of cold air over Russia, and then the hot air right next to it. Now this is what sets up the storms, the abrupt weather and the abrupt storms, when you see the cold air meeting up with the warmer air. Here's precipitation and clouds. Look at all this rain in the North Atlantic. See, it's raining on Iceland even. Now here's all the snow, see, from Colorado down, actually Utah, and on down. I'm glad I've been studying this so that I can understand the extremes a little bit better. Otherwise, I wouldn't be understanding it. Now here's the jet stream. See this big hole? Let's go to the flat view. See, here's North America, and see the big hole here? It's just like it's chopped in two. And so the cold air is just zipping right down and settling, and there's another hole right here, and it goes all the way down across Mexico and over the Pacific, the hole, and then the jet stream picks back up. And see, here's another break in the North Atlantic, where after it goes up over England, and then it breaks. When it gets to Norway, it just completely breaks, and then it picks up. Then here's another break, and there's no stream. It's just, you know, a burst here, a burst there. But then this is awful. And same thing in the southern hemisphere. You see where it's coming down along the equator, and it's hard to tell if this is part of the northern jet stream or the southern jet stream. It's like, how do you know? And then it picks up here over Africa, so I guess it's part of the northern jet stream. But it can mix in with the southern jet stream. I've seen that too, where one comes down and then it swoops on down to the southern jet stream. So we're going to have more chaos as time goes on. It's going to be crazier and crazier with the weather, and floodings, rain, floodings, mudslides, then the earthquakes, and then the volcanoes and the fires, and I don't know how anybody's going to survive. I don't think we will. No, we won't. I mean, You know, we just won't survive. That's all there is to it. Because we're losing the ozone layer, and that's the main thing. We're losing that, and when that goes, we won't have an atmosphere, and everything will be like Mars then. Sea surface temperature anomaly. This is updated to Friday. See, it's still brown. Coming up from the North Atlantic, up in the Barents Sea, and up into the Baffin Bay. See, it's still red up here. And the North Atlantic. See all that red and pink. Now look, even with all that cold air, the sea surface temperature is red down here in the Gulf. That makes no sense. Here's the blob, the Pacific blob. And see, it's red around Japan. We've got red and brown here through the Mediterranean and the Black Sea, and so on and so forth. So the North Atlantic is up 0.6 C higher than normal. That's the highest. So I've been going a long time. This is going to be a long show. I've been having trouble uploading on the BitChute. So I've created a Rumble account. I've put the last couple of months of videos up on Rumble. You can go to Margo Empath, all one word, on Rumble and find my Rumble account. Subscribe to that, and then you know, I've been putting my recent ones up there too. We're just going to do a short Bible reading just to finish up. This is just one of my favorite Psalms, the 23rd Psalm. And I know a lot of people know it. And as we go into these uncertain times, we really need comforting. And we need spiritual comforting, because physically it's going to be difficult. It's going to be very difficult. The Lord is my shepherd, I shall not want. He maketh me to lie down in green pastures. He leadeth me beside the still waters. He restoreth my soul. He leadeth me in the paths of righteousness for his name's sake. Yea, though I walk through the valley of the shadow of death, I will fear no evil, for thou art with me. Thy rod and thy staff, they comfort me. Thou preparest a table before me in the presence of mine enemies. Thou anointest my head with oil, my cup runneth over. Surely goodness and mercy shall follow me all the days of my life, and I will dwell in the house of the Lord forever. So I love you all. I'll be praying for you. And if you haven't given your life to Jesus Christ, this might be a good time while you still have a chance. He is the way, the truth, and the life, and the only way to heaven is through Him. He came as our rescuer, to rescue us, to comfort us, to heal us, teach us, be our brother, an advocate, protector, all of those things, because He represented the Almighty God. And we're getting ready. We're getting ready to leave. So I love you all, and I'm praying for everyone. I hope you have a good week, and that you're safe, and that God's will be done in all of our lives. So I'll talk to you real soon. God bless you. Go in peace, and good night.